The Cheeto slowly burned, and the heat from the Cheeto transferred up to the can that was filled with the water, and the temperature probe was stirring in the water. We used a stirring rod to stir the water to get an even heat to the temperature probe. The flame died down as the Cheeto burned.
After burning the Cheeto, we massed it again to find the mass burn off. It turned out to be 0.993 grams, which is basically 1. Another crucial bit of information is the temperature change, or delta T. That turned out to be 20.3 degrees Celsius.
Okay, so 20.3 degrees Celsius, that's about 60 degrees. Okay, just imagine if you were standing outside, right now it's about 55 degrees. If all of a sudden the temperature after you lit one Cheeto jumped up to about 110 degrees. Okay? So in your eyes, okay, or in your minds, is that a lot of energy?
Yeah.
Yeah, right? To heat up a can of water from 21 to 40 degrees, so it was a 20 degree difference or a 60 degree Fahrenheit difference. That's a lot of energy. So you can imagine when you're eating a Cheeto in your mouth, okay, down into your stomach.
It's really good.
Okay? Yeah, it's really good, but how much energy is it giving you?
I feel energetic after eating.
So, let's kind of review a little bit. Okay, what I want you to do right now is inside your notebooks. We've just finished our video.
Mr. I'm getting how were you burning? Like how were you about to burn those? Tell us the story.
You make it wrong.
Okay, so what I want you guys to do is in your notebooks, okay, you're going to write a reflection that answers these 4 questions. All together it should be about 8 sentences. First thing that you should answer is, number 1, how much energy did the Cheeto release? So this is based off of what the temperature change was. Number 2, was an outside energy source needed? For example, did the Cheeto light up on itself? Like, did it light on fire on itself? Yes. Or did somebody have to light the Cheeto on fire?
Light the Cheeto on fire.
Okay, so what was it and why do you think you needed the fire? How come the Cheeto itself doesn't just light up on fire? If it has so much energy already, why doesn't it light up on fire? Number 3, relate how burning of a Cheeto is like when your body burns calories. So how is burning a Cheeto? Yeah, you guys saw how that Cheeto was burning in the light. How is that exactly like how your body burns your food and burns your energy and burns your calories? Okay, how does it convert? How is that similar to each other? And then number 4, how does your food get converted into energy? So how do you think when you eat your lunch, okay, how does that food actually give you the energy to do work? Okay, so I'm going to give you guys 5 minutes to answer these 4 questions inside your notebooks. It should be quiet. Okay, if you need to ask your partners for help, you're going to ask them quietly. Okay, so you should not be distracting anybody from working. Okay, I expect all of you guys to finish in these 5 minutes. Low to high. How much of a temperature change? 23. So that's a pretty big jump. So that's the kind of detail that you can add to explain in just a question. Okay. It's like you're saying the joke. You say the chicken and the hog. You get me? That's what you just said, essentially. So when we run, so how they burn that Cheeto, kind of like how your body burns. Yeah, that's what you're into. Yeah. So let's kind of reflect a little bit. Okay. Number one, how much energy did the Cheeto actually release?
2.3.
Okay. So we're looking. I don't really need a number answer, but I'm just looking to see, was it a lot? Was it very little? Was it kind of a lot? Okay. So what exactly? How much energy did you think the Cheeto actually released? Maria Martinez? A lot. What would give you that reason as to why it was a lot of energy? Like from the video, what kind of information did the video show you that gave you that impression that, oh, okay, it was a lot of energy? Okay, what about the temperature? What was the change in the temperature? It was increasing. And did it increase just a little bit or did it increase a lot? Okay, it increased a lot. Now, Carlos, also another thing too. Did the Cheetos stay burning for a while?
Yes.
Okay, did you see it just like light up and just disappear, or was it like slow?
It was like slowly burning.
Okay, slowly burning. So that could probably be another reason why there's a lot of energy in the Cheeto too. Okay, number two, was an outside energy source needed, and what was it, and why do you think it was needed? So Eric, did the student add any kind of energy to the Cheeto? Okay, what was that energy source? Fire, right? So they lit fire. So you can imagine in your bodies then, so Jose, think about it. If you are trying, you eat candy, okay? And I'll ask you this question, Jose. If you eat candy, does it require, do you think it requires or it needs energy to, your body needs energy to break down the candy that you just ate? What would give you that reason? Well, what did the student do with the Cheeto? Did she put in any kind of energy? She burned it, right? She lit it on fire. So in your body, do you think it requires energy to burn candy too? Like inside your body? Okay, so it probably does. Maria?
Could you do that with any condition?
You could do that with any kind of food source. Okay? I used to do it with Takis. Okay? That's how I almost burned down in school. Okay? Pedro?
So you have fire inside your body.
So it's not really fire, okay? It's like fire, okay? Because it's not real like, oh my God, you see a flame, you know, your body's gonna light on fire. It's more of like, it's that concept, it's that idea of, hey, you're burning energy. Okay? Alright, number three. So Jasmine, how is burning a Cheeto like when your body burns calories? Can you say it louder, please? Okay, it's burn. Say it again, because I want everybody to hear that answer.
It's taking the food and it's burning it into energy, and it's turning it into something else.
Okay, I noticed that you said something really important. It's turning it into something else. What do you mean by it's turning it into something else? Okay, turning what into energy?
The calories. Or the food.
The food into energy. Okay? So, food itself. I'm going to ask you this question, Jasmine. Food itself. Like you eat, let's say you eat a banana. Okay? Will the banana itself, like, give you energy? Or do you need to do something to does your body need to do something to the banana in order for it to turn it into energy? It needs to break it down, and then what is it going to do? And then it turns it into energy. Okay? So, because it's kind of like, I mean, that's a big question, right? Let's say Vanessa eats a banana, okay? Is she going to poop out a whole banana? No, right? Okay? Because she's going to want to, her body's going to need to do something, like break it down, burn the banana, okay? And turn it into some kind of energy first, okay? All right. So that kind of answers number 4, too. How does food get converted into energy? Their body must do something. Has to do something. Okay? At this point, I'm not going to tell you what your body does just yet. Okay? But Michael, do you have a guess?
Digest.
Okay? It had a lot to do with digestion. Okay? It also has to do with something called cellular respiration, which is what we're going to go on to. Okay? Alright, so let's take a little bit of notes. Okay? We only have 3 slides. Okay? Mamas.
Amen.
Okay? So first, Valentin, let's start us off. What is our topic about?
Energy.
Energy. So, what exactly is energy? So in this case, Yesenia, what is energy?
Energy is used to perform specific jobs and functions.
Okay, so this is kind of like what you should know energy as. But if you were to actually say, hey, what is energy? Give me a definition. There really isn't one definition to describe energy. Okay? What you should know is you should just know energy is used to do something. Okay? And that there are a lot of different types of energy. Okay? Now, this is biology. Are we going to focus on wind energy?
No.
No. Are we going to focus on, let's say water energy?
No.
Not really. Okay. Will we focus on light energy?
Yes.
Yeah, we would. Okay. Will we focus on radiation energy?
Yes.
No, not really. Okay. Right. So specifically for bio, we're going to focus on light energy, and it's also something called chemical energy. Okay, which is not on here. Can I move on?
No.
Yes. I forgot. I have to ask Valentin. Okay? Yeah.
So what's biology?
Study of life. Alright, so the next thing that we're going to introduce something called ATP. Okay? ATP. You probably heard this in your 7th grade classes before. ATP. It stands for adenosine triphosphate. And more importantly, Abigail, what is the energy used for the cell? What is it called? ATP, which is also called adenosine triphosphate. Triphosphate, okay? So adenosine triphosphate, and more importantly, you guys should know this as chemical energy. Okay? So let's think back. Nadia, did Jasmine mention something about how food gets turned into energy?
Breakdown.
Like it gets broken down, turned into energy? What type of energy or what kind of energy do you think food will turn into for your body?
Nutrients.
ATP. Okay, this is called chemical energy. Okay? So in your body,